6.2, we also talk about case 2, which is side-side angle. So we have two sides and an angle opposite one of them. One of the given sides is known as the ambiguous case. So if we know the lengths of two sides of a triangle and the measure of an angle opposite one of those sides, we can have three different results. One of them is it may not even actually form a triangle. And you can see that here at the first drawing that they gave us. You can see here where if our A is less than the height is equal to B times sine of A, then there's no triangle. Or you could have one triangle. And we see that in the second example, and we also see that in the last example there. Or you could have two different triangles, and so that would be the third example that they show us here, okay? So we're going to have to work a little harder on this one, and so I always think about this one. We always say it has to be side-side angle. It can't ever be angle side-side. Well, because when we spell it backwards, we know what that gives us, and that makes us work harder. So therefore, just remember, if it's a side-side angle, you've got to look for a second triangle. So that's why they call, this says case 3, but it's really case 2. The SSA is called the ambiguous case. Alright, so this is, I showed you these pictures here and talked about that's if our A is an acute angle. Now, we could also end up with our first angle, and they call it angle A, but it could be any of the angles, okay? Not necessarily angle A. So, you see here, but what if our first angle is an obtuse angle there that we know the side opposite of? And so you can see here it's an obtuse angle, and side A is less than or equal to side B, then again, we're not going to have a triangle, or we could end up with just one triangle if one of our angles is obtuse. Now, if our angle is acute, go back and look at this here. If our angle is acute, we have the choice of no triangle, one triangle, or two triangles. And we'll talk about how to find that when we go through this next example here. Alright, so if our angle, if one of our angles that we're going to have is an acute angle, then we could have one triangle. Well, we could have no triangles, one triangle, two triangles, If one of our angles is obtuse, then we can only have a no triangle or a one triangle, just kind of summing that up. Alright, but I know it's always easier to actually see it than just to listen to it. So let's look at example 2. So we're going to solve triangle ABC with angle B is 32 degrees, side B is 100 feet, and side C is 150 feet. We're going to round each answer to the nearest tenth. So I'm going to go ahead and set up my answer box. Now, I am going to have to be a little more cautious on my room because I see here they gave me a side-side angle. And I'll see that more when I plug it in the box here. So remember, if it's a side-side angle, we need to look to see if there's a second triangle. So, I'm going to leave some room underneath this to make sure that in case I have to do a second triangle, I can. So, I'm plugging in what they gave me here. And so, I know that I'm either going to have this box as my answer at least, or it could be a no solution if so I'll box that after we hit that. But, let's see. First thing we're going to do is we're going to find an angle. Because we know angle B and we know side B, and we know side C. So let's go find angle C first. Now, angle C is going to tell us what kind of triangle we're going to have. So remember, if it's an acute angle, I could have a second triangle, okay? So let's set this up so I know information about B. So sine of B over side B is going to be equal to sine of C over side C. And so when I plug in what I know, angle B is 32 degrees. Side B is 100. I'm looking for angle C, and side C is 150. So again, we're going to cross multiply and divide. So we get 100 sine of C equals 150 sine of 32 degrees. Divide by that 100. So we have sine C equals 150 sine of 32 degrees over 100. Now, if you wanted to put that in your calculator and get an estimate, you could, but we're still after angle C, remember? And so to get an angle, we're going to do the inverse sign. So I'm going to take the inverse sign of that fraction. So personally, what I would do is I would plug the 150 sine of 32 divided by 100 in my calculator, and then I take the inverse sine of that answer. So I wouldn't try to do it all at once because then you got a lot going on, but that's my personal way that I would do it. And so when we do this, we find that angle C, rounded to the nearest tenth, is 52.6 degrees. Now, that's an acute angle. So that means I have the possibility of a second triangle. So I'm going to go ahead now and I'm going to set up answers for a second triangle. So angle A, angle B, angle C, side A, side B, side C. Now my given information doesn't change. So angle B is still 32 degrees, side B is still 100 feet, and side C is still 150 feet. Everything else will be different. So to find, and I'm actually going to call these, I'm going to put a little prime symbol by all of them so we can keep track of which is which as we're working, okay? So to find angle C here, you're going to take, because now remember, when you do the inverse sine, that's going to be in quadrants 1 and 2. And that's why you have to check for the second triangle, because angle C could have been a quadrant 2 angle to give us the, for the inverse sine to be positive, which it would have been. So, excuse me. So what we're going to do is we're going to use that 52.6 degrees as a reference angle. So that means that this quadrant 2 angle right here has a reference angle of 52.6 degrees. So we're going to take 180 minus that 52.6 degrees, and that's going to give us our angle C prime here, the angle C of the second triangle. And so we end up with 127.4 degrees. Now, to make sure that this second triangle works, let's go find angle A. Because if I can't get a positive answer for angle A prime there, then it's not going to work. So I said angle A, but let's go find angle A prime. So we're going to take 180 minus the other two angles added together, so 32 plus 127.4. And so we find that angle A is equal to 20.6 degrees. Because that is positive, that means I do have a second triangle there. Now I'm going to go through and I'm going to finish solving both of the triangles just like what we did in example 1. Alright, so since I'm almost done with the second triangle, I'm going to go ahead and finish it. I'm going to go find side A. So we know we're going to take sine of, I'm going to use B because that's what was given. Sine of angle B over side B. This isn't going to give me much room. I'm not going to do this here. I'm going to have to do this up here. Alright, so sine of angle B over side B will equal sine of angle A over side A. So let's plug in what we know. So we're going to cross multiply and divide. And so A is equal to 100 times sine of 20.6 degrees, all divided by sine of 32 degrees, which gives us 66.4. So I know side A prime there is 66.4 feet. And then I just need to finish off that first triangle now. So let's see. I think I can fit this in right here. So angle A, remember it's going to be 180 minus the other two angles added together. And so that's going to give us 95.4 degrees. And then for side A, we're going to have to do the same thing we did for side A prime, okay? So we're going to use sine of B over side B equals sine of angle A over side A. So we're going to cross multiply and divide. So I have A times sine of 32 degrees equals 100 times sine of 95.4 degrees. Divide by that sine of 32 degrees. And so we get A is approximately, I got 187.9. And it's in feet. So we ended up with two triangles and we've solved both of them. So those are both my solutions. So all of this here is our answer.